have a quick understanding about the difference in factor analysis and principal component analysis. As we know, both of them are techniques of multivariate statistics. What does that mean? That means that there are numerous data which are involved, and the number of variables which are involved are extremely high, and as a result what we need to do is to reduce the number of variables, and therefore this technique is also known as the data reduction technique. So one common thing in both of them is that we are reducing the data. Now you might say that our lecture intended to talk about the differences. Why are you focusing on the similarities? Because once we know the similarities, we would understand how the method of data reduction is different in the two techniques. Now what would happen under a principal component analysis versus a factor analysis? I give you a very simple trick here. Factor analysis is used mainly when human traits, human abilities are used, a human behavior which is more complex in nature. However, principal component analysis used with general findings. Let's say I went on to a survey. I want to understand the socio-economic status of a village. I can use a principal component analysis. How? I have a questionnaire in hand. That questionnaire has 100 questions. Now what I would do is I would have 10 of the questions which are similar and talk about health, another 10 talk about topics related to education, another 10 talk about topics related to sanitation. So what I am trying to do is I am using those variables V1, V2, V3 till V10, and I am chalking them down into a new component. And what is this new component? This new component is nothing but this new component is health in first case, education in second case, and so on and so forth. So in a principal component analysis, we are creating linear combinations. Along with the linear combinations, what we try to do here is that we create all of a new component. Clear? So we create a new component that exists. Now, the next important thing is, each of these variables I have taken, I need to assign certain weights. How would I determine those weights? Those weights are determined based on eigenvalue. The detail about this we have covered in our detailed lectures, the link for which is given below in the description on statistics, where we have covered principal component analysis into further detail. Coming on to factor analysis, two very important things that you must know. First, it is focusing on the hidden variable, or what we say latent, and therefore it is interpreted in nature. Now only if you understand these two concepts, everything is crystal clear. What do I mean? Something that you cannot see is taken into account in factor analysis as a factor. So in factor analysis we take factors. However, under principal component analysis we take components into play. That's another major difference that you must understand. So I give you a very simple example. I take 4 subjects. What are my subjects? My subjects are English, French, Maths and Physics. Now I say the child is good at English and French. English and French, if they are scoring good, you can say yes, the child is good at English, good at French. But what is the hidden trait? The hidden trait I can say here is the language ability. The next thing is Maths and Physics. What is the hidden trait under Maths and Physics? The hidden trait under Maths and Physics is, let's say, mathematical, or I can say technical ability. Now, what do we mean by hidden trait? I cannot actually visualize what is technical ability. I cannot see a person and say, yes, good at technical ability. No. But if the person is doing good at maths, good at physics, good at science subjects, we can say, yes, the person has a sound knowledge about technical abilities. So what we do under factor analysis is, we can understand these two groups in general and differences between these two groups. On the other hand, we can also understand intergroup differences. For example, I can say the person has good language ability but not that good technical abilities. Or I can also say the person is good at English but not that good at French. Probably good at one language, not good at another language. So what we can understand under factor analysis is the unexplained or the error variances that also happen. The variances which are caused due to some other factor other than the two that we have mentioned, we call those as the unexplained or the error variance or the specific factors that affect it. So this was the basic understanding about factor analysis. I hope the crystal idea, the basic idea between what is a principal component analysis and what is a factor analysis is crystal clear. So that's the most important big question when it comes to a researcher. What technique should I apply for reducing my data? For reducing your data, the best way is to understand what kind of inferences you can take from the data, whether you can create all of the new component or you can understand the underlying things that exist between those components, and based on that you decide whether you apply a principal component analysis or a factor analysis. Detailed understanding of both of those along with the mathematical component is available in the description below, so follow that link. Thanks.